I'm going to be going over the DNA replication fork for RLA5. So it starts off with this DNA strand right here. You see the top one is 3', the bottom one's 5'. And off the bat you can tell that the bottom one is the leading strand because the replicated DNA is going to go from 5' to 3' into the replication fork. So off the bat you can tell that the bottom is lagging or leading and the top one is lagging. The process starts right here with topoisomerase. It unwinds the DNA before it reaches the replication fork, and then at the fork the helicase unzips the two different strands. Then the primase, which you see here and here, they both make RNA primers which start the replication. On the leading strand, from 5' to 3' into the replication fork, the RNA primer starts, and then the DNA polymerase is what actually copies the DNA from the template strand. And that also goes from 5' to 3'. And then on the lagging strand, DNA always copies 5' to 3'. So it has to go away from the replication fork. Therefore, it has to do it in segments, and this is why DNA replication is discontinuous, because the lagging strand has Okazaki fragments. And there's constant stops and starts with RNA primers and DNA polymerase, constantly starting and stopping. And then once the primer is made and the DNA polymerase starts and it reaches a new primer, the exonuclease eliminates the primer here, so therefore it stitches the two different strands together into one strand, and that is done by ligase. It gets rid of all the little nicks in the DNA. So that's that process. And then on this side you can see the Pol alpha right here lays the primer and starts the DNA polymerase. And this is done on the single strand bonding proteins, and as soon as the Pol alpha lays the primer, the single strand bonding proteins start to disappear and get lost as DNA polymerase takes over, and Pol alpha gives the strand over to Pol delta, which extends the lagging strand, which creates those Okazaki fragments. And then on the leading strand, Pol epsilon is what constantly synthesizes the DNA as the process goes on. And then the process is bidirectional because it has two strands going in opposite directions. So that's why it's bidirectional, as the two forks. And it is semi-conservative because there is one strand is the parent strand, which is the template strand, and the other strand that is synthesized with it is the daughter strand. So that's what gives it its semi-conservative replication. And then, as I said earlier, it's discontinuous due to the lagging strand being broken up into different segments called the Okazaki fragments. And that doesn't happen on the leading strand because it's 5' to 3' into the fork, instead of on the lagging strand, it's 5' to 3' away from the fork. So.